So here it is again. We're going to put this in. This is our x, that's our y. We're dealing with time and height. So this is L1, L2. Make a scatter plot of the data. What polynomial function would best fit? Justify your selection. So we're going to do that. This would be 3.1, 7.5, 10, 12.4. Please let me know if I make a mistake. I'm going to go zoom stat. This looks like, in my opinion, based on being a flare, right? You know it's going to go up and then back down. We're looking at a quadratic here. So a quadratic function. Since a turn is visible in the plot, okay? So you kind of see something like that. That would be good enough. If you want to do your scatter plot on the side, that's fine. So determine the equation. We're going to go stat, calc, quadratic regression, and we're going to come up with the equation. Just keep in mind, it's not always cubic quadratic. It could be linear as well. Linear is very much alive. It's not going anywhere. But they tend to go with cubic and quadratic more so. So I'm going to go stat, calc, quadratic regression. Feed it what it needs to be fed with. And there is your equation. Is that what you get? That's what I have on my key. So I want to talk about the window right now. Okay, that's good enough. Let's talk about the window real quick before we move on. And I will ask you, maybe later on I'll give you an entry for your study sheet to help you out with that. But when you hit graph, it's a pretty good graph. The points are all in there, but please listen carefully. I would say you go to your x min, and I kind of look at the x max, what I have there. I will change that to -5 or negative something in the negatives. Maybe I'll go -2 in this case. So x min negative and y min, because it's bigger numbers that we're talking about here, I'll go -5 there. But you want to have a negative in the x min and y min, and then you hit graph again. That will ensure that you see the y-axis and you see the x-axis. Okay? And on top of that, I'll clear whatever else I have here. It's too messy. Okay? And I also have to chase the curve to the right, so I'll go x max 35. I'll try that. That's a pretty good graph. So please don't think zoom stat is it. You will probably have to change it. Okay, so maximum height, we just find the max, second trace 4. There's a point really close to it, so it could be that it's the same as one of the points. I don't think that's going to happen on the test or exam, but this is 11.65, 124.38. That's the coordinate. But the maximum height is 124.38 feet. That would be a full mark right there if you actually narrow it down to this number. Okay, you have to have units. The flare ignites 4 seconds after launch. How high is it when it ignites? They're basically saying when x is 4, what is y? That calls for second trace value. X is equal to 4. So we'll figure out y. That's 73.75. 73.75 feet. That is your answer. Okay. The flare drops out of sight when it gets below a height of 75 feet on its way down, for how long would a flare be visible? So 75 feet is indication of we need to figure out the time when the height is 75 on its way down. So we're going to make y2 equal to 75. We're going to figure this out on its way down, what that time is. Second trace intersect, enter, enter, enter. 19 point, for now, I'm not going to round to 2 just yet. I'm going to go 19.1977. The reason being is I need to know for how long would the flare be visible. Let's envision this. I know that after 4 seconds, somewhere here, I start seeing it. It ignites, it goes to the top, and then when I get to a height of 75 on my way down, somewhere here, it stops being visible. So I need to figure out what is my time here? How much time has gone by to get to here? 4, right? You can see it until it gets to here. What is that time? 19.1977. So I will give you today, I will give you a mark for figuring out this. So if you have that, you're already halfway there. We need to figure out delta t. So we need to go 19.1977 minus 4. That is 15 point, now I can round 20 seconds.
What if I got 15.9?
Is it because you, I don't know, that's a rounding error somewhere, right? I don't know, but it's a round, so 1.5 out of 2. Okay, state the domain and range on the visible portion of the flare's flight path. Guys, keep in mind, the flare has a beginning and it drops on the ground, but we don't care about that, we just care about the visible part. So for my domain, I actually have the numbers I need right here for my domain. This would be 4 to 19.20. If you round it there. 1 mark for that one. For the range, what's the lowest for the visible path? The lowest is 73.75. Yeah. So here it's no longer visible. Also here it's not visible. It's only visible here. From 4 till once you get back to 75, which takes 19 something seconds. So we subtract these two because when you subtract, you figure out how much time is happening here, like actually what you're interested in. Does that make sense? Yeah. So in general, if you do this, if you draw your line and you find 2 times and you subtract them, you're figuring out how long you spend here. You know what I mean? This is just a little offset. But you're basically, if you find this time and that time and you subtract, you're finding the time spent here. Twice. Then you're telling me from here to here, right? 75 is right there. So you're finding how long does it stay at or above 75. And knowing, right? Okay, when I write these questions, I don't always want it to be cookie cutter exactly the way the lesson went because the province, I don't know what they're going to do. I don't know what they're going to do. That's the most frustrating part for me. Is like, I could just keep it basic, right, the whole time, and then they decide, no, we're going to curveball every single question, right? So I want you to, like, be critical, and you guys are actually pretty good. When I walk around, you're always like, but it could be this, right? Like you sometimes question my question. And sometimes you have very valid points, like it's not specific enough. So I like that you're always reading and making sure you kind of rule out certain things before you decide what to do. Okay? I'll give you 1 out of 2. 73, 75? What's the highest this thing ever gets to? I know that, right? I know that the maximum height is right there, so this should be 124.38. Half a mark for the numbers, half a mark for the bracket. So if the numbers are wrong, but your brackets are square, you still get half a mark. So this is 2, 4, 5, 6, 7, 8. Yes? What happened? Let me see if I... Like while you were working through this?
Yeah, while I was working through it.
Okay,
yesterday.
I will... Okay, let me see. Maybe we can help everybody with this. What happened?
Yeah, because when I put it into my calculator, I got 0.866.
Mm-hmm.
So that's what I put here, but then it led to me getting everything wrong by like a couple decimal points.
Excuse the interruption, Mr. Newfield.
Did you
Contact the office,
type
please.
this in manually?
Contact the
Yeah.
office.
Okay, so you wouldn't lose any marks. But I would prefer you doing this. I would prefer if you run it, tell it to paste it. You go alpha trace Y1. If you hit enter, it'll take all of this into, sorry, it'll paste it all in there. And then use that one to answer everything else.
All right.
I think you would have actually lost half a mark.
All right.
Yeah, for the whole thing.
All right.
Yeah. So this is a teaching mode. I'm just gonna let you know, if you write down your equation and you type this in manually, you would lose half a mark if the answers are off later on. Once. You would lose half a mark once, and that's it. So don't enter it manually if you want to get full marks. That's all I'm saying. Let the calculator paste it. Okay, it should look like this, right? Okay, backside, graphing, yay. This is something that you should be able to do, right? When they give you points, you can use the points to graph, but you have to be careful here. Again, I did the curveball thing because I say graph the scenario, assume that the restriction you stated in F are still in place. So only the visible portion, visible path only, right? That's what we're gonna focus on. So I added some data here again. So I'm looking at I'm gonna do my inventory here real quick. I know that at 4, I am at 73.75. So that's definitely an important point. The other one is that after 19.20, I am at 75 on my way down. So these are definitely, this is the start, and this is the end of the path. So that's most definitely there. Let me ask you, what else should you include on top of these 2 points? What else do you think would be critical to include? The vertex, yeah, the vertex, the turning point. Okay, so let's do the vertex. We also know that one. What was the vertex again? 1165, 124.38. Those 3 points, in my opinion, are good enough. Okay, so the maximum x value is 19, so 20-ish, and the maximum y is 124. So I'll go up to 140, 150, or something like that. So let's see here, 5, 10, 15, 20. Good news, the province usually gives you a grid. That's another good news. So 5, 10, 15, 20, that I can stop there. I'll just make sure I call this time in seconds. It could be minutes, days, hours, so be careful. and this is going to be height in feet. Okay? Let me zoom out. So I need to go 50, 100, 150, 200. That'll do it for me. Okay? So 473. This is 4. This is 75. So 73 is just a little under. Then I have 11.65. That's close to 12. All the way to 1. This is 125, 124. Close enough is good enough. Then 19.20. And I'm at 20 here. This is 25. 20 is right there. So I'm going to go from the vertex, I'm going to go to that. And from the vertex, I'm going to go to that. Okay. So that's what it should look like. No. This looks very wrong to me. I hope you realize that there's something wrong. 1920, 75. 75 is right about there. So it should be cut off right there. There we go. And then slap your equation onto that. Overkill. The grid is overkill. Like it's too big, but whatever. You decide what scale you want to use. Okay. So 3 marks. Scale, labels, shape. Shape being, like I would have lost 1 mark for shape because I went past my domain and range.